I'm shopping for a solution. Because when we start buying smart clothes that don't just light up, but connect to the net, or self-driving cars that talk to each other to avoid accidents, or connect our dustbins so that they can tell us when they need to be emptied, we're going to need a better mobile network.
We have previously been talking around 50 billion connected devices, and we think that that may even be a bit conservative nowadays. So at least 10 times the number of connections that we have today.
And 4G can't cope with that?
No. 4G was not designed to cope with that.
In 5 years, Ericsson Research reckons our thirst for mobile data will multiply tenfold. An increase in things like sensors connected to the net will need a network that won't just help firefight, it could help deliver a very different world. This is not a shopping trolley. It's the world's first 5G mobile device with indicators. And yes, that is about a 4 gigabit per second connection. You could stream 100 Ultra HD movies with that, and let's face it, this beast is practically big enough to show them all. The first 3G and 4G mobile prototype devices were even bigger than this, so the race is on to try to fit one of these inside your pocket. But it's not just about blistering speeds. One of more than 20 global companies working together on 5G has a very special deadline. Japan wants to play host not just to the 2020 Olympic Games, but also the world's first commercial next-gen network. Let's face it, at the moment it's tricky to get more than a tweet out of a packed stadium. There are just too many people all using the same mast. But the decentralized nature of 5G could in effect see each user be allocated with their own mast, or more precisely, antenna. These smaller base stations have up to 256 antennae closely packed together. Using smaller millimetre wavelengths makes this tight packing possible. And they're operating at super high frequencies, 10 times higher than our handsets today, resulting in those blistering data speeds. Advanced antenna tech will form data beams that will track and focus on devices only when needed, and will use more of these smaller base stations, rather than a single mast, to dodge any objects that could block the higher frequencies, like buildings. This is the world's first chamber set up to test the new high-frequency, high-speed data technology. What's happening here is they're getting a 3D profile of exactly what the data beams that this antenna is capable of sending out look like. They want to find out just how many data beams could be sent to a single device. Having 8 or even 16 beams means greater reliability for systems we may want to depend on in 5 years' time, like remote air traffic control towers servicing multiple airports, or remote surgery. Of course, security and safety of this system will need to be tied down, as will its sustainability. But that's why these researchers are busy, trying to find the perfect solution for a mobile network that will work in 5 years' time. And one thing's for sure, this won't be the future.
Can you hear me? Hello? Dan, is that you? Dan? Hello? Dan? Hello? Line to the future's quite bad at the moment. Anyway.